Let's start with our next experiment. Experiment number 7, to verify transient and steady state analysis of RC and RL circuit. In this, we are taking two circuits, RC and RL circuits, and we'll verify the steady state and transient using the MultiSIM software. This is the circuit diagram. It's for theory calculation. We'll have another circuit in that we'll do for the software of MultiSIM software. With that circuit diagram, we'll simulate it in MultiSIM software and get the output waveforms and the output values, whatever it's required to verify using the transient and steady analysis of RC and RL circuit. It can also be solved using theoretically. The theoretical values and the practical values matches. So let's see here. This is our circuit diagram. We'll use two types of keys, SPTD and SPDT. Here there are resistor, inductor. This is a voltage, means the source. It's a step voltage, maybe we'll check it. And this is a capacitor, and this is an inductor. And this is in inductor, to measure charging and discharging we are using current probe, whereas for capacitor we'll be using a voltage probe. And see, we'll have two steps. One is we'll on it, then this source will give power to the inductor, then it gets charged and we get a charging curve like this. Then we'll open it, then again we'll run, then we'll get a discharging curve like this. Okay, same thing will be done for this also. We'll get charging and discharging. In this we'll also use the initial conditions. I'll show you in the software how to do that. Start with the software part. First we'll take that voltage source, go to place, here components, then under components you can check the diagram what you want. Under all groups, go to source. In source, first check in power source. We know it's not there in power source, it will be in signal voltage. Here go to step voltage. So we got the source. The check, there is value is not milliseconds, is 1 US. Okay, so it is a 0 to 5 is there, we need only 1, so take 1 U. No, I think it's not like that. Let's delete it and take 1 again. In here, go to this step time, here click 1 U. So don't change anything else, we got 1 US. Then take an inductor, go to basic. Here you will find inductor, resistor, capacitors, everything. First take a resistor, okay, place it here. Then take an inductor, place this here, rotate it. Then to find the switches, go to switch, then here SPDT and SPST will be there. Click on and check whichever you want, take that. SPST we are taking here. To rotate, click on that, and CTRL-R, it will get rotated. Then connect it. To confirm, check that. It will show the wire, then it is connected. Next, we will connect this with the resistor. It's wirely we are connecting. Then inductor we are connecting. Then connect it like this. Take another resistor. Now that resistor you place it here, rotate it with the help of CTRL-R. Then connect it into this common node. Here we will place the ground also. To get ground, go to source, power source, ground. Okay, put the ground there. Now it is the switch, open and close. First we'll close, then we'll go to interactive here. In interactive, we'll go for initial conditions, user defined. There we'll put end time. See here, it's interactive. Go for transient. Okay, here user defined. In initial conditions, user defined. Then the stop time, put it for 5, 0 to 5. Okay, then save it, then run. 1 minute. I think we have not put the appropriate values. This is 1k resistor, not it is 10k resistor, and it is 40, not k, it's actually 10 ohm, and it is 40 ohm, and here it's 5 Henry. Okay, put a current probe here, so only before we didn't get the result for inductor. Then 40 ohm, 10 ohm, 1 US, 5 Henry. Now let's run it. The transient we have previously given, that is the correct one. So we have got the charging curve. Okay, now let's check for discharging curve. Open the switch, then double click on the inductor. Once you double click on the inductor, here we'll have to put the initial conditions. To put the initial conditions, here click on initial condition. The initial condition is 2.4. Click on OK. Now run it. You get the discharging curve. Okay, so here we completed the first part of this RL. Now we do the same thing with RC, but for different circuit. Okay, we are taking a different page here, blank page, create. For this we need the source, signal voltage, step voltage. We are taking step voltage here. Then we put its value, it's same 1 US. Click on OK. We got 1 US here. Take the resistor. To take resistor, go to basic, resistor. OK, we need 2 resistors here, so we'll be putting 2 resistors now, and a capacitor is also required. Click on OK. Get the capacitor. We'll put the voltage source here as per the circuit diagram. For rotate, then we need switch. Under basic only we'll get the switch. Here there is a switch. We need SPDT. Click on OK. Then rotate it as per the requirement. So connect the switch, then the resistor, then the resistor will be connected in series with the step voltage. Then complete the circuit here, same with here, and it will go to the common ground here. Okay, from here go for source, power source, ground. Okay, we have placed at the ground. We'll give the appropriate values. 2 microfarad we'll put here. Instead of 1, now it's 2 microfarad. And this resistor value is 80 ohm. So it is 80 ohm, and this is 70 ohm. And 1 US, the charging and discharging of that capacitor, what we were seeing earlier using the steady state and transient. Here I have corrected the circuit. In transient it is 0.001, it is saved. Then the switch should be closed. Here this should be closed, okay? So now it is closed. Then we run. No initial conditions. Voltage probe is there near the capacitor, this one. So we get the charging of the capacitor. Okay. Then we'll put the switch that side. Then we also give the initial conditions to 5. Initial conditions 5. Okay. Now run the transient. Let that be same as previous, 0.001. When we run, we get the discharging curve of the capacitor. So both the conditions of RC and RL regarding the transient and steady state analysis is done. Thank you.